This is SkyMath. Video 4, The Road Ahead. In the first three videos, we talked about the functions that Sky defines at the beginning of his paper. And that was quite a lot. It takes time to dig into these different expressions and the background and understand what's really going on. So now, we're over an hour into these videos, and we've only covered half a page of a 20-page paper. But I want to say, don't get discouraged because actually, I feel like we're halfway there. Maybe 40%, maybe 40% of the way there. The rest is going to move a lot quicker, believe it or not. Now that we're familiar with Sky's function definitions, um, it's time for me to give you an overview of the rest of the paper. In this video, I'm not going to go into any real detailed proofs. Instead, we're going to look ahead. We're going to see where we're going and we're going to understand for the future, why are we talking about the particular things that we're going to be discussing coming up. So let's begin that. We saw in the last video how W of n is presented as part of another function, f of s, which looks sort of like the Riemann zeta function. Where the zeta function has a 1, though, f has W of n. Sky is going to state that he will prove that f converges for all values of s with real parts in the range 1/2 to 1. Now, without getting too into the weeds, this is very similar to an expression that would imply the Riemann hypothesis is true. That little space between 1/2 and 1 is really all that remains to be addressed about zeta. Except we're not talking about zeta here, right? We're talking about Sky's function f instead. And the way he's going to show that that works for f is that he's going to sum W of n from 1 to capital N. And he's going to show that as capital N rises, that expression converges relative to the square root of n. Remembering Wn is that function that maps, all the counting integers onto the unit circle in the complex plane. Now, the expression that I have highlighted here is formatted a little bit differently, but meaning-wise, that should be terribly familiar to you because if you watched video 1, we talked about the Landau hypothesis, right? The summatory Liouville function, that if you proved that that converges relative to root n, then it would prove the Riemann hypothesis, right? And we know that W of n is related to the Liouville function. It maps onto the top half or the bottom half of this unit circle using the same criteria that the Liouville function works with. When we show that the sum of all the W of n's converge relative to root n, it turns out that's all we need really to show that f converges for the real parts between 1/2 and 1. Just like proving the Landau hypothesis is enough to prove the Riemann hypothesis. So instead of coming at the Landau hypothesis directly, he's setting up a sort of parallel proof that substitutes W of n for lambda of n and substitutes f of s for zeta of s. And it proves the things that we want to prove, but it proves them about what you might call the alternate versions of those functions that mathematicians have been working on for so many years. Then after that, after he's completed that sort of parallel version of the proof, Sky is going to introduce another parameter, little m. We're going to have f sub m of s. We're going to have w sub m of n. We're even going to have a psi sub m of p to the k. So a whole additional dimension gets added to the structure with that extra input, the letter m. And everything looks pretty much the same, except for this little input, this letter m. So what's it doing? You know, like at what point in this do we use that m? If we look into the definition of psi sub m, finally we see why we are doing this. We see that the m is there. It's going to reduce the angle theta by dividing psi by m. Right here, see? Everything else is the same except for that. And then we're going to go through a lot of the prior arguments, and we're going to see that just like f sub m also converges, and et cetera, et cetera. We go through all the same logic, you know, check that it still works. But now, let's take a look at what we've done. We have f sub m. That's not just one function. It's a whole series of functions, right? One for each value of m. M is a positive integer here, right? And it's all based on reducing the angle theta by a factor of m. Why would you do that? Well, did you ever ask yourself, where on the complex plane does that original Liouville function lambda of n map the integers to? Right? W of n is Sky's like parallel version of lambda. If W of n sends the integers to the unit circle, where does lambda send them? Well, lambda only returns positive and negative ones, right? So it sends every integer to one of two places, here and here. And when? Well, if you recall, all the points that W mapped to the top half of the circle are mapped by lambda to the value positive 1. All the points that W mapped to the bottom half of the circle are mapped by lambda to minus 1. And now, with the introduction of little m, we have divided psi, and therefore theta, by an arbitrary integer m. And we go through all the proofs and we show that that converges too. So it converges when m equals 2. It converges when m equals 3. It converges when m equals 10. It converges when m equals 100. It squeezes the points into a tinier and tinier little space until in the limit, as m goes to infinity, W just becomes the lambda function. And just like that, the Landau hypothesis is all squared away. And therefore, Riemann as well. As they say in the business, QED. But, you know, the devil's in the details. Has Sky really done it? I have to confess, I'm not 100% sure, okay? But I've taken a critical eye to all of it. And for me, like the longer I work to understand what's happening here, the more I think about it, guys, I think he has. But of course, it's not for me to decide. The paper will have to go through peer review. A lot of much more powerful minds than mine will ultimately be brought to bear on the subject. And as for me, I'm just going to keep making videos. I'm going to be honest with you about the parts that I struggle with. We'll get to that. And maybe we can help each other out, Leave a comment if you think you can improve my understanding. So, I will be back next time, back up near the beginning of the paper, and we are going to be discussing the topic of density.